In this third part of our example, what we're going to do is calculate the dead plus live load deflection and then the live load deflection. We were given the left, middle, and right moments for dead and live were here. They're larger than, obviously, than the dead load moments. And I'm going to skip all the details, but all three were cracked, and so you had to use that long equation, this one here, new for 2019. You have to do that for A, B, and C because all three were cracked. And I'm going to skip the details, and and these details aren't even in that last video. It wasn't worth it. And these are the moments of inertia. And what I did, that was pretty onerous to type into my calculator. I had to do it like 3 or 4 times, make sure I got it right. And so I decided I was not going to do it 3 more times. And so what I did instead was I did it on Excel. So I made this spreadsheet where if you type in these 4 things, actually, so you type in, well, I guess you type in mcrack, and the spreadsheet calculates 2/3 mcrack. So you type in those 4 things in this spreadsheet, and it does all the rest for you. It tells you if it's cracked or not cracked, and if it's not cracked, it returns I gross, and if it is cracked, it does that long equation. I checked it. This works. And then you can type in the weights you want for left, middle, and right. I did 15%, 70%, 15%, and it averaged it out to, for example, that's 32.24. So you can see these numbers here: 39, 38.96, 30.67, 32.83. Those are those right there. Okay. And I've posted this spreadsheet so you can use it as well. I didn't color code MA, MCrack, iCrack, and iGross. Maybe I'll highlight the cells you need to type numbers in. Okay, once you have those 3, you need to average them 15, 70, and 15% to get 32.24. And that's what this is here. Again, that was done on the spreadsheet. And so we now have our 1 moment of inertia for the whole beam, and we can use the same formula as before. So this time you put in the big moments, middle, left, and right. So you put in these moments, and you put in that moment of inertia, the 32.24. You do all that, multiply the numerator by 12 cubed, put everything in, and again, you can watch that 5th video to see the details, and you get 0.59 inches for dead plus live. And so what we are doing this all for is to get the live load deflection. And the live load deflection is dead plus live deflection minus dead. And so we got 0.59 just now, and in the previous video, 0.14 for dead. And so when you subtract them, you get 0.45 inches for the live load deflection. And the next video, I will do the long-term deflections.